All right, today we're going to go over study guide number 2. It's over solving inequalities, the absolute value, and solve systems of equations by graphing. Sorry it's a little late, but I was watching the Indians game, and then they won, so go Tribe. Hopefully we make it to the World Series. For numbers 1 through 6, remember they're all simple inequalities. There's only one inequality symbol. So you just use PEMDAS in reverse. The most important thing to remember is if you multiply or divide both sides by a negative number, then you flip the inequality. Don't forget your number line. Number 1, I have 5 minus 2x is greater than or equal to 27. So I'm going to use my PEMDAS in reverse. I'm going to get rid of 5 from both sides. I get minus 2x is greater than or equal to 22. Now, I have to get rid of the negative 2 in front of x, so I divide both sides by negative 2. Remember, that's our rule. All right, so since I'm divided by a negative, I'm going to flip this inequality. So I get x, instead of greater than or equal to, I turn that to less than or equal to, and I make it negative 11. So my final answer, if x is less than or equal to negative 11, remember you do have to have a number line. So I'm going to put negative 11 on the number line. I'll put 0 on there as well. It's a closed dot. And I'm going to shade to the right. And make sure you put your own arrow. You've got to put an arrow for your shaded region. So I shaded to the right. It's a closed dot. All right. That's it. All right, number 2. Same exact thing. We're going to do PEMDAS in reverse. I get rid of the addition. That's why minus 4 from both sides. I have 1/2 x is greater than negative 10. Now, to get rid of the fraction, I'm just going to multiply both sides by 2. I get x is greater than negative 20. Make my number line. I'm going to put negative 20 on my number line. I'll put 0 on there as well. It's an open circle because there is no bar. I'm going to shade to the right. And there we go. It's greater than 20. If you really want to quickly check it, you can just plug in 0. And 0 makes a true statement, so I know it works. Number 3, I have 4x minus 1 is greater than 14 minus x. Before I use PEMDAS backwards, I'm going to move all the x's on the same side. So I'm going to add x to both sides because I always move the smaller of the two. 4x is bigger than negative x, so I don't move the 4x. I get 5x minus 1 is greater than 14. Now I just go back to PEMDAS backwards, so I add 1 to both sides to get rid of the subtraction. I get 5x is greater than 15. Divide by 5, divide by 5, because that's how you get rid of multiplication. I get x is greater than 3. Now, remember, I did not flip the inequality because I divided by a positive. I make my number line. I'm going to put 3 on my number line. I'll put 0 on there too, just because I like to put 0 on there. It's an open circle, and I shade to the right. And that's it. All right, number 4, same exact concept. I have multiple n's, so I'm going to add 7n to both sides first, because I want all my variables together first. Those cancel. I'm left with 8n minus 6 is less than negative 4. I'm going to add 6 to both sides. I get 8n is less than 2. I divide both sides by 8. I get n is less than 1/4. If you gave me 0.25, that's okay as well. I do prefer 1/4. I make my number line. If you want to put a bunch of different numbers on there, you can. I'm just going to put 0. Maybe I'll put 1 right here. There's 1/4. Okay. It's an open circle. It's less than, so I shade to the right. And there we go. If you want to test 0, 0 should work. When you plug it in, it does make a true statement. All right, number 5, we have 5 plus 5x is greater than negative 4 times the quantity 3 minus x. Remember, you're going to distribute that negative sign first. So it's going to turn into 5 plus 5x is greater than minus 12 plus 4x, because remember, negative times the negatives are positive. Now I'm going to subtract 4x from both sides. I get 5 plus x is greater than negative 12. I'm going to subtract 5 from both sides. I get x is greater than negative 17. Make my number line. We'll say negative 17 is right here. We'll say 0 is here. It's an open circle. It's shaded to the right because it's greater than. That's one of the main reasons I have the variable on the left, because it points that way. And if you want to check, plug in 0 in to see if it works. It does work, so looks good. All right, number 6, I'm going to distribute the negative 2. So I get negative 8 plus x is less than or equal to 8. I add 8 to both sides. I get x is less than or equal to 16. Make my number line. There's 16. We'll put 0 right here. It's a closed circle because it's less than or equal to. It's got the bar. I shade to the left. All right, and that's it for number 6. All right, remember, number 7 and 8, it's a compound inequality because there's 2 inequality symbols. It's an and because it doesn't have the word or. So if you look at 9 and 10, it has the word or. You're going to write the middle twice. You don't change it, and that's what your graph should look like, sort of like that at the end, either with closed dots or open dots. All right, so the first thing I'm going to do is I'm going to write this middle twice. So I'm going to write negative 5 less than or equal to minus n minus 6. I put the word and I write negative n minus 6 less than or equal to 0. So I took this middle, I wrote it twice. All right. Now I'm going to do these one at a time. So I'm just going to rewrite the first one. So this is a rewrite. It's not a flip. I'm just going to write this part on the left, minus n minus 6. I'm going to write this part on the right, negative 5. And Pac-Man guy is eating n minus 6, so he keeps on eating n minus 6. So although it kind of looks like a flip, it's not. Just some students thought it was easier to rewrite it and put the variable on the left right away. Now I use PEMDAS backwards. I have the opposite of n is greater than or equal to 1. Now this is not solved because I have the negative sign, so I have to divide by a negative 1. All right, that gives me n. And since, remember our rule says that if I have to divide by negative 1, I have to flip the inequality. So this less than or equal to or greater than or equal to becomes less than or equal to negative 1. I'll do the same thing again. I add 6 to both sides. I get minus n is less than or equal to 6. Divide by negative 1, divide by negative 1. I get n, and once again, my rule says since I divided by negative 1, so the rule says that I have to flip this inequality, it becomes greater than or equal to negative 6. I make my number line. I put negative 6 on the number line. I put negative 1 on the number line. I even add 0, which you don't have to. They are both closed dots. It's bigger than negative 6, so I shade to the right. It's less than negative 1, so I shade to the left. And there's my graph right there. And it looks just like what I thought it was going to look like. So that's it for number 7. All right, so number 8, exact same concept as number 7. The first thing I'm going to do is I'm going to write this middle twice. So I have negative 2 is less than negative 2n plus 1. And negative 2n plus 1 is less than or equal to 7. So I wrote the middle twice. Now I'm going to rewrite this. So I'm going to rewrite it. I'm going to put negative 2n plus 1. I'm going to put negative 2. And this is not a flip. This is a rewrite. It's not a flip because Pac-Man guy is eating negative 2n plus 1. He keeps on eating negative 2n plus 1. Subtract 1 from both sides. I get negative 2n is greater than negative 3. I divide both sides by negative 2. Remember, that's our rule. That's our rule. It's negative. So when I write n, I have to flip it. It becomes less than. I'm going to put positive 1.5. You might put 1.5. That's okay as well. All right. I did that side all by itself. Now I just do the next one. I minus 1 from both sides. I get negative 2n is less than or equal to 6. Divide by negative 2, divide by negative 2. I get n is greater than, remember our rule that tells me I have to flip it, greater than or equal to negative 3. I make my number line. I have negative 3 on my number line. I have 1.5 on my number line. Now make sure you know that 1.5 is bigger and it's on the right. 1.5 also has an open circle. Negative 3 has a closed circle. That's important. See how they mix match this time? I'm bigger than negative 3, so I shade to the right. Remember, I don't go through the circle. I'm less than 1.5, so I shade right there. And it looks like an and graph. All right? And that's it for number 8. All right, numbers 9 and 10, they're also compound inequalities because the problem has 2 inequality symbols. It's an or because you see the word or. You're going to use PEMDAS backwards on each half. So you're going to do one side at a time. One side at a time. And then you're just going to remember that rule. You're going to flip it if you multiply or divide by negative. And then this is what your graph should look like at the end. All right, if you don't get that type of graph, you messed up somewhere. All right, so I have negative 5x minus 4 is less than negative 1, or negative 2x plus 1 is greater than 11. I'm just going to focus on the left side. I add 4 to both sides. I get negative 5x is less than 3. I divide by negative 5, dividing by negative 5. I get x is less than negative 3/5. You might write negative 0.6. I'm okay with that. All right. Now, the second half, I'm going to subtract 1 from both sides. I get negative 2x is greater than 10. I divide by negative 2, divide by negative 2. I get x is greater than negative 5. Now I'm going to make my graph. All right. They're both open circles. It's less than negative 3/5, so I shade to the left. It's greater than negative 5, so I shade to the right. And there's my graph. All right, number 10, I have 4x plus 6 is less than 22, where 6x is greater than 36. I'm going to do the left side all by itself. I minus 6 from both sides. I get 4x is less than 16. Divide by 4, divide by 4. I get x is less than 4. Divide by 6, divide by 6. I get x is greater than 6. Make my number line. We'll say 0's here. There's 4. There's 6. They are both open circles. It's greater than 6, so I shade to the right. It's less than 4, so I shade to the left. And that is what an OR graph should look like, so I know I'm on the right track. Looks great. All right, so 11 through 18 are absolute value equations or inequalities. You're always going to write it 2 times no matter what. All right, you're never change inside bars. So if it's inside the bars, you're never going to change the signs or anything. The only thing you're going to change is the second sign after the equal or inequality. And if it's inequality, you're going to flip it. Now remember, you're going to use PEMDAS backwards. And you're going to remember your flipping rule if you have an inequality. That means if you multiply or divide by a negative. And remember, if you want to know what it's going to look like in OR graph, if it's greater than, right, you'll have 2 arrows going out. If it's an AND graph, it's less than or less than or equal to. And then if it's and, that's going to be your kind of hint. All right, so I'm going to write it twice. I'm going to write 2x minus 5 equals 9. I'm going to write 2x minus 5 equals negative 9. I'm going to add 5 to both sides because I'm using PEMDAS in reverse. I get 2x equals 14. I divide by 2, divide by 2. X equals 7. There's my first answer. I'm going to add 5 to both sides. I get 2x equals negative 4. Divide by 2, divide by 2. X equals negative 2. There's my second answer. So if you have 2 equations, you should have 2 answers. All right? And that's it for 11. All right, number 12, I have the absolute value of x minus 8 equals 11. I'm going to write x minus 8 once equals 11. Then I'm going to write it again, x minus 8. This time it's equal to negative 11. I add 8 to both sides. I get x equals 19. There's my first answer. Add 8 to both sides. I get x equals negative 3. There's my second answer. That's it from the 12. You can plug them both in and check, and they should both work. All right, I have 2/3 x minus 9 equals 18. So I'm going to write it once. 2/3 x minus 9 equals 18. And then I'm going to write 2/3 x minus 9 equals negative 18. I add 9 to both sides. I get 2/3 x equals 27. I'm going to multiply by the reciprocal. You could divide both sides by 2/3. You could multiply by 3, then divide by 2 in the next step. But I'm just going to multiply by the reciprocal. Those cancel, so I'm just left with x equals 27 times 3 halves is going to be 81 halves, or I'm going to put 40 and a half. You might put 40.5, that's okay too. You might put 81 over 2. That's okay as well. Okay, all those are fine. Because remember, the decimal terminates. Now I'm going to do the same thing again. I'm going to add 9 to both sides. I get 2/3 x equals negative 9. Multiply both sides by 3 halves. So I get x equals negative 27 over 2, which most of you will put negative 13.5. And that's okay as well. Okay? So there's one answer. There's another answer. That's it for 13. Number 14, we have the absolute value of 1/2 x plus 4 equals 6. If you wanted to multiply everything by 2 to start to make that fraction go away immediately, you can do that. I'm not going to. I'm going to say 1/2 x plus 4 equals 6, and 1/2 x plus 4 equals negative 6. I'm going to minus 4 from both sides. I get 1/2 x equals 2. Multiply both sides by 2. That will make the fraction go away. I get x equals 4. There's my first answer. Look, same exact concept. I'm minus 4 from both sides. I get 1/2 x equals negative 10. Multiply both sides by 2. I get x equals negative 20. There's my second answer. And that's it for 14. Number 15. I'm going to write it twice. 4x plus 10 is less than 20. This tells me it's an and because it's less than. So I'm going to write the word and just to remind myself at the end what the graph should look like. Now it's 4x plus 10 is greater than negative 20. So look, I'm going to flip the inequality to start right there. I'm going to minus 10 from both sides. I get 4x is less than 10. Divide both sides by 4. I get x is less than 5 halves. Maybe you, 5 halves. Or maybe you just put 2.5. Either one of those are okay. I like 5 halves a little bit better. Minus 10 from both sides. I get 4x is greater than negative 30. I'm going to divide both sides by 4. Notice, I do not flip the inequality because I divided both sides by a positive. It doesn't matter that my answer is going to be negative. It will be 15 over 2, negative 15 over 2, but maybe you put negative 7.5. I make my number line. I'm going to put negative 7.5 right there. I'm going to put 2.5 right there, which means 0 would show up like right there. They are both open circles because there's no bars, and it's greater than negative 7.5, so I shade to the right. It's less than 2.5, so I shade to the left. So it looks like an and graph because it's shaded in the middle. If you want to check 0, 0 should work. But real quickly, see the absolute value of 10 is less than 20, so it does work. All right, number 16. Right away, I see that greater than. It tells me it's going to be an or. I have 20 plus 1/2 x is greater than or equal to 20. So I write it twice. 20 plus 1/2 x is greater than or equal to 20. See, I didn't change that one. I write the word or. 20 plus 1/2 x. This time I flip it to less than or equal to, and I make it negative 20. So notice I flipped the inequality. I'm going to solve. I'm going to get rid of the 20 first. I minus 20 from both sides. I get 1/2 x is greater than or equal to 0. Multiply both sides by 2. 0 times 2 is just 0, so I get x is greater than or equal to 0. Now, I'm going to minus 20 from both sides. I get 1/2 x is less than or equal to negative 40. Now I'm going to multiply both sides by 2. I'm multiplying by a positive 2, so it doesn't change my inequality. I get x is less than or equal to negative 80. I make my number line. We'll put negative 80 there. We'll put 0 here. They're both closed circles because there's a bar underneath the inequality. It's greater than or equal to 0, so I shade to the right. It's less than or equal to 80, so I shade to the left. And that looks like an OR graph to me, so I think I did it right. That's it for number 16. All right, 17, exact same concept. 12 minus x is less than or equal to 24. This is an and because it's a less than. All right, now I'm going to write 12 minus x. This time I'm going to write greater than or equal to negative 24. Because remember, the rule says that we have to flip that inequality when I first start. When I change the sign, I change the inequality. I'm going to subtract 12 from both sides. Get the opposite of x is less than or equal to 12. Now I have to divide both sides by negative 1. I get x is greater than or equal to negative 12. Remember, because of that being negative, that's our rule, says I have to flip that inequality to greater than or equal to. I'm going to minus 12 from both sides. I get the opposite of x is greater than or equal to negative 36. This time I have to divide both sides by negative 1. Remember, when I divide by a negative, that's our rule. So I have to flip this inequality. So I get x is less than or equal to negative or positive 36. Make my number line. We'll put 36 right here. We'll put negative 12 right there. We'll say 0 is about right there. They are both closed circles because they have a bar. It's bigger than negative 12. That's why I like the variable on the left. It tells me which way to shade. It's less than 36, so I shade to the left. And there's our and graph, just like we thought. Okay? That's it for 17. All right, 18, exact same concept as everything before. I write it once. 1/2 x minus 8 is greater than 12. It's an or because I see that as a greater than. I write 1/2 x minus 8. This time I write less than negative 12 because remember the rule says you must flip it. I add 8 to both sides. I get 1/2 x is greater than 20. I'm going to multiply both sides by 2 to get rid of my fraction. So x is greater than 40. I'm going to add 8 to both sides. I get 1/2 x is less than or equal to negative 4. Multiply both sides by 2. I get x is less than negative 8. So make my number line. Remember, 40 is bigger, so 40 goes on the right. I'll put negative 8 over here, which means 0 is kind of like right here. Doesn't have to be perfect. They're open circles. So I shade to the right because it's bigger than 40. I shade to the left of negative 8 because it's less than negative 8. And that does look like an OR graph, just like I thought. So I'm done with that one. All right, 19 through 22 are basically checking a solution. So you're going to plug and chug. Remember, your ordered pair is written x, then y. If both are true, then it's a solution. If either one is false, then it's not a solution. Remember, answer in a complete sentence. All right, so we're going to go on 19. All right, so 19, we said we have a system of equations, negative 4x minus y equals 25, negative 3x minus 2y equals negative 16. I'm going to plug in negative 6 for x. So I'm going to just check the first one. Negative 4 instead of x, I write negative 6. Minus instead of y, I write negative 1. Notice I put in parentheses on purpose. You can just plug the left side into your calculator if you want. And it's just the way it looks, and it will do all the work for you. I'm going to do it in my head. Negative 4 times negative 6 is 24. Minus times the minus is a positive, so it's 24 plus 1 is 25. That's true. Now, that doesn't mean anything yet. They both have to be true. So that just means I have to check the second equation. Just means I have a shot. So now I'm going to write the second equation, instead of the letters, I write empty parentheses. Now I plug in negative 6 and negative 1. Negative 3 times negative 6 is positive 18. Minus 2 and minus 1 is plus 2. That equals negative 16. No, it doesn't. 20 does not equal negative 16, so it's false. So guys, the most important part is once you do all this work, don't just stop and forget to answer it. Alright? So say since 1 is false, -6, -1 is not a solution. And that's how, this is my answer. Okay, so don't forget that. That's your answer. Alright, number 20, I'm going to plug in -3. So I say the opposite of blank space plus 2 times blank space, that's supposed to be equal to 3. So I say the opposite of -3 plus 2 times 0, does that equal 3? Well, that's gone, so I get, does 3 equal 3? It's true. Now I have to check on the second one. 10 times -3 plus 0, does that equal -30? Well, 10 times -3 is -30, -30 plus 0 is -30, -30 always equals 30. So remember, I have to answer the question. I can't just not answer the question. I say, since both are true, -30 is a solution. That's it. All right, 21. Check the first one. 2 times -8 minus -2. Does that equal -14? 2 times -8 is -16. Minus minus is plus. -16 plus 2 does equal -14. That's true. That means I just have to check the next one. So I say 9 times -8 minus this and this. Oh, I didn't mess up. Minus -2. That's supposed to equal to -70. 9 times -8 is -72. Minus minus is plus. So -72 plus 2 does equal -70. That's a true statement. So I say, since both are true, -8, -2 is a solution. That's it. All right, number 22, I have the ordered pair is 5, 3. I'm going to check -x minus y. So I'm going to say the opposite of 5 minus 3, does that equal 8? -5 minus 3, that is -8, does not equal 8, so that's false. So you don't even have to check the second one. As soon as I get one false, I say, since 1 is false, 5, 3 is not a solution. And you're done. Alright, that finishes part 1. I'll finish the second part tomorrow. Remember, this is at the end of the period tomorrow. So this goes up to 22. There won't be any graphs on this. Once again, go Tribe.